All right, we're ready to start our working drawing. So your choice, if you have created a template, then you're welcome to use it. Otherwise, we will use the drawing. And let's see, when we hit OK, it's going to ask us once more if you are only seeing the ISO versions, then the only show standard based on the standard. And if you're using the ANSI standard, then it's going to default and you're not going to see any of the ISO. So I would recommend if you're going with this uh, default template that you use the B size just because it doesn't take up as much uh, real estate for the title block. All right, so it did not, I told it previously not to launch the model view. You are probably looking at something like this. So if I check that box, this will come up automatically. I like the option to be able to do model view or go to the view palette. So the tool post is open, so we can just go to next. I would like to show it in the exploded state, and there is the exploded view. And we really only need the isometric for our first sheet, which is going to show the construction. All right, so if we right click and go down to the tables, we're looking at the bill of materials. We need to check, we're just going to do top levels. There's not a lot of sub-assemblies here. So the description, this one did get a part number and has more on the description. So we'll go ahead and leave the description this time. We might want to put more in for the washer. SolidWorks abbreviates. Most vendors have no idea what a stainless steel flat slotted set screw is, or the narrow flat washer or hex nut. There is, the abbreviation just doesn't uh, translate well. All right, so in our annotations, we're going to be looking to auto balloon. I think on this one, I'm going to stack everything to the left, which doesn't look terrible. There's a bunch of stuff crossing, but I think that'll be okay. And when we highlight, we'll be able to take the magnetic line and drag it just a little bit to shrink and stretch those. 1 and 4, I think I will. Those are a little too close for crossing over, so yeah, we'll call that close enough. So on the view palette then, if we refresh, well, I guess I need to pull down and do the tool post, and then it refreshed. I would like just a standard, maybe we'll go dimetric, and we'll put in a dimetric view just to kind of show the collapse state. And I guess it fits in there okay. All right, so at this point, if you want to do single sheets, you would save this, open up another um, another drawing sheet, put the part in. I still tend towards the multi-sheet, so I'm going to come down to the bottom left and add sheet, the um, little icon at the end of the row. And then we can go back to the view palette. And if I use the ellipse, the dot, 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 then we can bring in the tool post body. And I would like to, the front view, the right view, the top. Probably not going to need a bottom view, but I would like to detail that a little bit, and the isometric. Okay, so that gives me pretty much everything. I don't know that I need the back view because those are going to be tapped all the way through. We just need the location for them. Maybe the tool post will be next, so hitting the add sheet to bring in the next, we'll do the dot, dot, dot. And the bolt is going to more than likely be a manufactured part. So even if we modify it, that's interesting, that view. Okay, yeah, I'm okay with that view. Just making sure it's not flip-flopping on me. we'll go ahead and bring these in, and then on the next one, next pass, I'll worry about setting the scale. All right, so we had the wedge, and so the wedge we can do a front, a right, an isometric. I don't know that we need to do a bottom. So let's, oh, that was the open. I needed the palette. We're going to go to the adjusting screw. And if we go to the right side, again, those are a little bit on the small side for this size sheet, so we'll adjust the scale. So just going around, realistically, this is a really nice piece, and we may be able to find a, let's go with bottom, but we may be able to find one of these with a square nut in our vendor. But this is, nowadays I would look at this and go, this is going to be an expensive little piece. I don't know that if I can replace this with a purchase part, this one's going to be, on our cost-effective scale, going to be one of the first ones to get analyzed if there's really a necessity to have that that flanged square nut. All right, where did we make it over to? Probably the washer. So let's go to the front. And we'll do something like that because I'm thinking I will probably rotate this just so I can see the side, but I don't know that there needs to be anything different there. And one more, I think we'll have everything. The purchase components, I'm not worried about bringing those in. Oh, that was the washer again. So let's just Control Z. We need the adjusting nut. There we go. Okay, so front. Let's go to the back, to the side, to the isometric. Nothing on the interior detail that I'd really need a section view. So I have the assembly, 1, 2, 3, 4, 5, 6 components. And in my assembly folder, just going to do a check real quick. That we have the assembly, 1, 2, 3, 4, 5, 6. And, yep, so 1 and 7. All right, that makes sense. So the if I'm missing anything, I'll come back and pick it up. We can go back to our list. So the tool post body, the bolt, the wedge, adjusting screw, washer, adjusting nut, screw, and then the set screws. All right, so that one looks reasonably well sized. Don't think that we're going to need anything different there. Let's go 1-to-1 with this. I'll probably go with the isometric view back to a half scale. I mentioned on the manufacturing side of this would be one that I would consider making the shaft with the thread and then the block and either pressing the two together and welding it, because removing that much material to make the shaft and the thread, and then that's going to fall back into the is it cost effective, and I think we could probably weld it or secure it in such a way that it's going to provide the clamping force that we need to position the tool post. All right, so those all look pretty good. I think we got enough room. With the alignment, notice the front view is going to be the parent, and the child views are going to move with it. And so whenever I move, I see that little line indicating that it is a child view. So let's go back to the one-to-one, and even that one may be a little bit small. So don't know what that line is. The cosmetic thread. So the cosmetic thread did not go all the way down. All right, so indicator that I need to open that part up and make an adjustment. So on this one, maybe we would go 2-to-1. So we have a better view, but that one looks a little bit big. So let's go to the custom scale and 1-to-1. And same thing, let's go to 2-to-1. And that one I don't see as being very intrusive over the view, but I do want to rotate that. So it's always going to warn you whenever you rotate, try to do this before. So now I have the ability to dimension that. But if I had applied dimensions to this and went to rotate it afterwards, it would delete those dimensions. And then the last one, again, we'll go 2-to-1. All right, so I think we've got everything. So this going through this process, setting these up, let's go ahead and save this. This will just be the tool post drawing. Again, name them what makes sense to you. But going through this process, my first pass on the drawing just kind of gets everything in. The second one, we set the scales, add additional views if we need them. Then I have the exploded view and my bill of materials to kind of refer back to see if I've missed anything. Again, the 3 purchase parts, actually 2 purchase parts, we're not going to mess with as far as making a drawing for. It's, we've got a part number. We're going to put a part number in the description of what we've selected, and that just becomes something that goes through, whatever that procurement process is. All right, so again with the alignment, notice that the parent view kind of moves and the other views move to it. If I'm moving just one, it's showing it left and right, will not move up and down. So we haven't had a need to break alignment, but on the right mouse button, there is an alignment, and we can either add or remove alignments if need be. All right, so we're ready to start putting dimensions in. The requirement for the final is that you put enough dimensions in to show me that you have a pretty good understanding of the process. I'm going to go through my normal, what I would do for just about any drawing is just get the dimensions in and then refine the process, since that's probably going to be a toleranced item there. We'll bring it out. Normally I'd pick the baseline and just go to that size, but the variation, we'll see what happens there. All right, so the overall, and we already have an overall there, so I don't need it. We will need the angle. And let's go with a distance from there to there. And really that can float. It doesn't have to be too exact. The one thing that kind of jumps out is I will probably need a detail view. So let's go back into the drawing, and we're going to pull a detail view so that we can highlight that item and make it a little bit bigger. So the custom scale, let's go up to 2 to 1. And we'll pull the label out a little ways. All right, so the reason for that is it's not overly critical that we just need that relief so that whatever slot this is sitting in, that geometry doesn't hit a sharp or try to rotate it or generate any kind of what am I trying to say? The angle because it doesn't seat correctly. On these guys, probably will pull them again. I don't know that they're that critical, and since I got the angle, that means I got the center mark. And we just need a couple of location dimensions. All right, and again, if you're using the ANSI standard, yours are going to be inside of the center line or on the outside where these ISO lies on top of it. And not sure what the dot was there, but we'll go ahead and put these in. And since I pulled that off of the front, we'll just go ahead and make that the datum. All right, so we've got those. Comes back to what do I need to do on this one? Actually, it's kind of looking like I don't really need that view, or yeah, probably don't need that view, but let's go ahead and leave it for now. Yeah, I want to put something over there. I'm just not sure what. I'm going to say maybe this tolerance for the plus minus dimension that we'll need on that. So, okay, so the other thing that we need to do then is go to the hole callouts. So the hole callout is going to combine these up and give you the counterbore, the through hole, the tapped holes. All right, also the tap drill, if one is needed. All right, so we've got all of those in. All right, so if I don't find any dimensions to put on this one, I'm pretty much just going to need to delete it. I do like the layout otherwise. So let's move on to the next. And we're going to go to the square. And then we'll have the length and the overall. All right, and then let's go to the more dimension, and the more dimension at the bottom will be the chamfer. So the chamfer and then the one of the faces. And we will also see if the hole callout will do. Nope, I think it is just the dimension. I always try to do the hole callout there. And we'll set those to the half 13, but it did not give me a distance, so we need to pull the distance over here. All right, so that looks pretty good. I'll line those up a little bit better. Okay, into the wedge, overall distance, the angle. Let's set an end for reference. Now this, we remember, was our tolerance dimension, so it actually needs to be 3 decimal places. If we're going to leave everything else at 2 decimal places, then I need to override that one. And then also look at its being, I think they did those as limit dimensions. So minus 0.002. Or actually, no, we need to grow that one or allow it to get bigger, because then the shaft is going to be allowed to get smaller. All right, and then the width dimension. All right, so if I think of those gap tolerances on this pass, then I will go ahead and apply them, but really the next pass is where we go through and we do the fine tolerancing. So we have our dimension, and actually, let's see what this one looks at as. Looks like it's 2 to 1. Yeah, that's not bad. We'll probably take that. And custom scale, that can go back to 1 to 1. And we have the 4.5. Let's see if we can pick up the chamfer from the more dimensions. Let's see the head size. Oh, that's not a chamfer. Let's go smart dimension, and we'll put in our size, 5/16, 18, and then the width is also our tolerance dimension. So let's at least put that one in 3 decimal places as a reminder, and we'll go back and we'll set the limit on it on the next pass. We'll talk a little bit more about tolerances. All right, and then the outside dimension, that should put us pretty close. All right, we've got a few dimensions on that one. Okay, so there was a relief, and that relief was the inside. Went to the 7/16, 14. So, all right, we'll go 7/16, 14. That one's a little hard to figure out what was going on. Probably going to need one more view then for, maybe not if I put in the square. Depends on how the symbology pulls out on that one. All right, so 0.34. And then we need the chamfer dimension again. The length. Let's go ahead and bring the length up. All right, don't know what it picked, but it didn't like something. All right, so I'm just going to escape and start over. So the 1.75, I would probably go ahead and make that one from the end, because that makes a little more sense. Let's go ahead and put a radius on that. So the chamfer on this one is going to be a little strange on the call out. Don't know that I'm going to be able to pick that one. And because it kind of goes into the cut revolve, it's going to end up being a more of a sphere, or more of a spline. So put the 1/2 inch. So in this case, I may just put a note so that it gets attached 40 or 30 degree. I think it was, and we'll add the symbol. Have to go back and verify that one, but I'm not sure there's an easy way to do that other than it comes up tangent. So maybe let's see where that view comes in. We will go back into the drawing, projected view. bring that in, and basically it knocks the corners off. So now let's see what that number ends up being. So if I go between those two, now it's actually a distance of, wow, that was a weird distance. I don't think that's what I had in mind, but if we put that in there, so 0.05. Let's just go ahead and make that one a reference. I don't know that I'm getting any good description out of that, so and if we're going to go that route, we'll put 0.044 by 0.044. Now there is a symbol. Oh, it went to diameter. Well, it does match the diameter, so being the square nut. All right, let's move these over a little bit, kind of clean up as we go into the slotted washer. It's a radius of 0.44. I would like that one to be a diameter. And then we'll go to the inside. We can do the overall. And then the relief. And then we know that that is going to also be a toleranced item. So let's go from 2 to 3 decimal places. And we'll see if there's any other spots where we need to add in those tolerances. All right, so we'll move this along. We have the diameter. We have the OD. And the whole call out should pull up for the 5/16, 18 through. We have the two chamfers. I don't know that I'm going to worry about maybe on the optional pass, we'll go back and split the jog line. But one of the things we can do is just tell it that there are 2 times for that chamfer. And then because we know that there's a knurl, and we'll just give it a coarse description. All right, so fine knurl, coarse knurl. Since this is going to be a tightening, the coarse gives you more of a grip. What else do we need? The depth and the overall. Okay, so we've now made a dimensioning pass. Going back through, let's look at the bilateral on that one. I would want it to be able to get a little bit bigger. So let's stay with the limits since we started with the limits. So the slots get the ability to go a couple thousandth bigger. And then we don't really need anything on that one. This one was the 186. It should be able to go on its limit 2,000 smaller. And then this one we already did as a bigger. Nothing really here to work with. And then let's go ahead and delete that dimension, and we'll look at this from the standpoint of it needs to fit into the slot, but I don't want it to grow too much bigger. 656. So most of the T slots that I've worked with lately have been 5/8. So maybe the 16 millimeter 5/8. So that one seems a little bit large. But let's go ahead and make it a minus dimension, and I'll be a little more generous with it and tell it that it can be 5 thousandths smaller. So smaller means minus. Okay. So does all of that that geometry make sense? Okay, and we already have the depth there. A location. So since I missed the location on that one, we'll go ahead and put it here. Make sure I'm not duplicating anything. Nope. And we'll build that through. All right. So the next process that we aren't going to do in this this phase. Let's go ahead and save, and then Control Q to get rid of my ghost lines. You know, if you get some portion of these dimensions in, this is what I would consider up for review. Going through for redline, what did I miss? What mistakes did I make? And then the next step in the process would be looking at this from the standpoint of what GD&T do we need to put in? What geometric tolerancing, flatness, parallelism, critical dimensions we've identified already with our limit tolerances, but then going to that next step of building out the geometry to be able to control those fine details. All right, so that completes the final project, and the next videos will be the optional, let's take it to the next level.